Hi, this is a presentation of wireless LAN security, and it's part of my CCNA2 class. I'll try again. Hi. 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 This is a presentation of wireless LAN security, and it's a part of my CCNA3 class. I think we all know that there are a lot of security issues regarding wireless networking, and we will have a look at a couple of them in this chapter, where we will try to look at some of these wireless threats. For instance, there are different types of attacks. When we look at the wireless threats, we will see that there could be wireless intruders, and this can be, for instance, where you drive by with your laptop in a wireless mode and try to find out if there are any open access points. There could be interception of data, where you also listens in and try to be like a man in the middle and try to get hold of the data that are sent back and forth. You can have denial of service attacks, where you just send out a lot of noise on the wireless network, which makes the wireless network go down. And we can have something called the rogue access points, where you, for instance, try to make the users believe that you are the real access point. But we will look at some different ways. When you look at the DDoS attacks on a wireless network, it is typically something we can experience if we have improperly configured devices or configuration errors. But also, we can have malicious users that are intentionally interfering with the wireless communication. It's quite easy to interfere because we are sending information out into the air. There could also be users that no. Hi, this is a presentation of wireless LAN security, and it's a part of my CCNA3 course. I think we all know that there are a lot of security aspects in regards to wireless networking. We will have a look at some of them in this chapter. If we look at the wireless threats, we can have different types. For instance, wireless intruders, where you try to break into a wireless network. You can have interception of data, where you just listen in and try to collect the data and read them. You can have denial of service attacks, where you do something to make the network stop working. And you can have these rogue access points, where you try to deceive yourself and try to not deceive yourself, you try to disguise yourself as a real access point and makes the user try to use your access points instead of the real one. And thereby you can also operate as some kind of a man in the middle and see what is happening. If you look at the DDoS attacks, these can also be divided into two different types. You can have them which are intentional, where you do something to try to interfere the signal. You can buy different stuff on the net that does that. You can also build your own interference device that just sends out noise in the same wavelength as the wireless networks are using. It can also be different errors that you have set up, or if you haven't configured your wireless network correctly, it could be easy to just break in and do something with it. It can also be accidental, where you, for instance, if you're using the 2.4 gigahertz band, you will see that there are a lot of interference, because all other kinds of devices that are operating wirelessly are also using the 2.4, and that is baby monitor. It could be a cordless phone. Microwave ovens are also very close to the wave or the frequency that are used by the 2.4 band, so they can also cause interference. And other wireless devices can also cause interference. So there are a lot of options there. You can also go in and look at the protocol itself and do something. This is when you're doing it intentionally. You can, for instance, send out a disassociate field or a frame, and then it tried to disconnect all the users. You can send a clear to send flood out, where when you're using CCNA3, you are waiting for the clear to send. And if you get a lot of these, well, then it doesn't understand, and then it in the end will stop transmitting clear to send frames. We can have a rogue access point, as I said, where you set up your own access point and give it the same on the same network, or on another network maybe also, where you try to make the users connect to your access point instead of the real one. There are a lot of tools today that can actually experience if there are a rogue access point present in your wireless network. We can also have, like, this is another way of setting up a rogue access point, is something called an evil twin, where you actually try to copy the settings of the real access point, and you're using the same SSID, and you're using more or less the same setup as the real one, but you're maybe closer to the users, so they will actually connect to your access points instead of the real one. And then you actually, what you do is that you just take the information within the access point that you have made, the rogue one, the evil twin, you look at the data, and then you send them on to the real access points. So a lot of the times this is called a man-in-the-middle attack, where the users don't really know that you are there and know what you're doing, but you can, you know, get access to all the data, and you can see what's happening, and you can actually change it also if you're really evil, and change it before you send it on to the real access point. So there are so many ways to attack a wireless network, and therefore we need some kind of security options. When we look at authentication, we can do it either openly, where we have no authentication or no passwords, or we can have a shared key password. And the shared key password can then be divided into different groups, whether you're using the WEP, WPA, or other WPA2, which are different types of encryption algorithm that these are using. The WPA is it uses an old algorithm, and there are a lot of known errors in the WPA, so you shouldn't actually use that if you're using, no, it's sorry. yeah, if you look at the different authentication methods, and we want to have a shared key, we want to have some kind of encryption implemented, we can have the web, which is an obsolete encryption protocol. Well, it's not, the web is not an encryption protocol, but it uses an RC4, which is a compromised algorithm. So you shouldn't use the WEP protocol for encryption. You should either use WPA or WPA2, which are using more modern and uncompromised encryption algorithms. We are using now AES, for instance, for the WPA or 802.11i standard. And they are also using the newest versions for authentication. The WPA is a more simple setup, and it uses TKIP for encryption. And that is, TKIP is the Temporal Key Integrity Protocol, and it's used by VPA, and it uses actually a web, but encrypts the layer 2 payloading uses TKIP and carries out a Cisco message integrity check. So this is like hashing that is combined with, which makes it a little bit more secure. But otherwise, you should use the advanced encryption standards, the AES, which are the algorithm used by WPA2. And it is the preferred method because it can also, aligns with the industry standard 802.11i. And it's a stronger method for encryption. And it uses also the block changing message authentication code protocol for the cipher. Yeah. So if it's possible, always use WPA2 with AES when it's possible. When you're looking at the authentication, there could be a personal, where it's typically you're using a pre-shared key, or you can have an enterprise model where you are using, for instance, a radius server as the authentication server. Because if you already have an authenticated user on the network, you might as well use that for authenticating the users on the wireless network as well. Whenever we have a pre-shared key, we will always have a problem with the security. Yeah. So what do you do? Well, and how to set it up. When you configure your access points, you're actually setting it up what kind of encryption that you want to work with. And if you have a radius server, you will set that up in there. Yeah. And that was it. Thank you.